In this video, we'll discuss solving inequalities with variables on both sides. There's only one learning objective. We've already spent a lot of time looking at solving equations and solving inequalities. Well, we're going to continue this path that we were doing before. If we put variables on both sides of an equation, we'd seen how to do it. We're just going to see that same strategy applies when we have an inequality symbol as well. So we want to solve inequalities with variables that are on both the left and the right hand sides. There are problems that look like this. So if this were an equal sign, we'd know that we'd just follow our PEMDAS CDIS mnemonic that we could use. It works the exact same way for inequalities. Start at the bottom, work your way up to the top. Do we have distribution? No, there are no parentheses for us to get rid of. Do we have combining like terms? Yes. And this is the new part that we have had. In this particular problem, we have variables. We've got the x on the left-hand side. And I'm just going to draw this line. You do not need to draw it. I'm just putting it here to further emphasize. We can see the variable on both the left and the right. So we've got to put them on the same side. How do you want to do that? Okay, since it's a positive 5, Sammy, you had it. One way we could solve the problem is subtracting 5x. We know that cancels on the right, so what do we get on the left? 3 minus 5 gives us negative 2x, absolutely. And that's going to give us a positive 6. We do not flip the sign because you never flip the sign with adding and subtracting. Do we have any more combining like terms to do? No. Okay, so that's done. Is there any adding and subtracting to do? No. All right, that's done. Go up to multiplying and dividing. Okay, so we'll say divide by negative 2. Okay, Jerry, you said flip it. Why? Yeah, because this number here is a negative, we need to flip. Absolutely correct, sir. So that would tell us flip the sign. We have our solution. And now we need to graph it. So we can come up and say 2, 3, 4. I'm sorry, it had a negative. I got to fix that because I was thinking positive 3, negative 4, negative 3, negative 2. Circle over the negative 3. Less than will tell us to the left. And no line because it's strictly less than, not or equal to. And that problem's done. All right, so here's our next problem. Solve and graph. Well, we can still use our same mnemonic. Starting at the bottom, do we have distribution? No. Combining like terms? Betcha. Yes. So which ones do you want to put together? We know, again, our x variables are on the opposite sides, left and right. Opposite sides will have to be paired with opposite symbols to move them over. So recognizing that this is a positive 1.5, you're absolutely correct, Jerry, that we'll subtract 1.5 from both sides and say, what do we get? Okay, 2.3 on the left. Okay, so that stage is done. There's no more combining like terms. Yep, our next step, looking at adding and subtracting, we will have to add 1.2. Go ahead and write it out. We know the pair plus minus will cancel on the left, giving us 4.6 on the right. Yeah, you are correct, Malia. With addition and subtraction done, our next stage is to do multiplication and division. Dividing by 2.3. Yep, got it, Mitch. 2.3 cancels. And 4.6 divided by 2.3. I see a lot of people are reaching for their calculators. Not a problem. A lot of times it's designed just to speed up our calculations. 4.6 divided by 2.3 is 2. So what about here? Do we flip the symbol? No, because we divided by a positive 2. This was a positive 2.3, so we do not flip. Okay, we have our solution. Let's graph it. Now, because this is getting a bit low on the screen, I'm going to scroll up. What do you want to use for the tick marks? 1, 2, and 3 works. So we'll say or equal to, less than or equal to. We've got it. And of course, I'm running through this quickly on the video because the class has already demonstrated they're really good at it, so we don't need to have the full explanation. And here's our third one. Now, to create a little bit more space, I want to, oh, did not mean to do that. Grab this and pull it up a little bit. Where should we start? Okay, distribution is our first step. I want to go over the distribution a little bit more slowly because when we had our last assessment on the distributive property, we noted that there was a little bit of confusion for parts of the class in this one. So what do we need to do for distribution? This outside number of 5 is going to have 2 pieces of multiplication. 5 times 4, and we would have the other one, 5 times x, that's 5x. Is there more distribution? Yeah, we have distribution on the right-hand side as well. So 3 times 6 paired with 3 times x. And that will take care of distribution. What's next? Yeah, we could combine the like terms by subtracting 3x. Those would cancel, giving us 20 plus 2x is less than or equal to 18. Any more variables left to combine? Okay, so that's done. Yes, sir, you correctly identified that we need to subtract 20 for our next step, which gives us positive 2x is less than or equal to negative 2. Addition subtraction's done. Yes, ma'am. Dividing by 2. Now, here's the question I want to ask you, Paul. At this stage, we were dividing by a 2. Do we need to flip the sign or not? This number is a positive 2. We're dividing by a positive. Because this spot here in the blue is a positive 2, this is what tells us do not flip the sign. So it's got to stay the same. X is less than or equal to negative 1. It's kind of amazing that we're winding up with so many less thans, 3 in a row. It's kind of weird. But we can graph that and then we'd be finished. What do you want for the tick marks? 0, negative 1, negative 2. That works. Or equal to goes to the left, and we've got it. Okay, what would we do about this problem now? Yeah, we can still start off with our distribution, the same as we did before. And I had this particular one picked out because this is the common mistake that our class was making. A lot of people were still making this error. And so when we distribute, we don't have a problem with getting the negative 2h. But I would like to point out, like one of the shortcuts that we were using, this is a negative 2 multiplied by a negative 4, which does give us a positive 8. that is not going to be subtract a positive 8. One of the pieces that we've been having some issues with are making sure that we actually get the signs correct here. Having negative 2 times negative 4, since it's positive 8, positives are the same as pluses, so it's plus 8. On the left-hand side, or I'm sorry, on the right-hand side, we have the same issue. Negative 6 times h, no problem, that gives us negative 6h. But we need to be careful with the signs when we're multiplying the constants. This would be a negative 6 multiplied by a positive 4. If you take negative 6 times positive 4, what do you get? That's a negative 24. Well, negatives and subtractions are kind of the same thing. We've seen that. So we could say subtract 24 just the same way that we would write a negative 24. Now, we know there are other correct ways to write this out, but for most people, this has been the correct method that has helped them actually do it correctly. If you've got another correct way to do it, by all means, be correct, but just make sure it is right. Okay, and then we'll switch to blue and say, with distribution done, what do we need to do to combine our like terms? Plus 6h plus 6h. Okay, that cancels. On the left-hand side, negative 2h plus 6h. Yeah, positive 4. Okay, then what? Subtracting 8. 4h. Subtraction never flips the sign. Okay, because the signs are the same, you're correct, sir, that we will need to add the numbers to give us a negative 32, which was actually those two stages. Divide by 4. Got it. Which gives us h is less than or equal to, not just 8 though, a negative 8, because of course a negative divided by a positive is still got to be negative. Okay, our number line, put negative 8 in the middle. I wanted to show you something that somebody else was doing when they had their last quiz. Not required. If we were to use negative 7, negative 9, it's completely fine. But there are other people that were saying stuff like, let's just count by negative 4s. It's perfectly fine to count by other stuff. You still wind up with the same idea that our graph is a filled-in closed circle because it's an or equal to. And since it's h is less than, we're still going to go to the left. So they're just different numbers. I thought it was cool, and I liked seeing it, so I figured, hey, I should point it out. Maybe more people will do it, and it'll look cool, and it'll make me happy and smile. Yes, I know I'm a nerd. So, okay, so solving graph. Now, yes, we've got decimals. It's not a big deal because calculators can speed up our number crunching. Decimals don't change the strategy. We'll still start at the bottom and still say, is there distribution? No. Do we have combining like terms? No. Do we have adding and subtracting? Yes. So we would need to subtract 2.59. And whether you choose to use a calculator to help speed up the process or you choose to do the work by hand, it doesn't really make a difference. I would look at it and say 5, 13 would become 12. That's 8, 7. We get 3.78 is less than 2.52p. Do we have any more adding and subtracting? No. Multiplying and dividing. Divide by 2.52. And of course, this is where calculators are the most beneficial because we know the division algorithm is a bit tedious sometimes. And just using the calculator speeds it up. Thank you, Malaya. She already did the number crunching for us. That's 1.5. But here's the part I'd like you to take a look at, Jerry. What do we got to do for this one? This is a piece that in the most recent homework people were making errors on. So I want to point this out because it's something that was tripping people up. Jerica, you correctly identified that we're going to flip the sign, or flip it so that we'd have P written on the left. But a lot of people were just flipping them without also changing the sign. We have to make sure that because this is pointing at the 1.5, it needs to stay that way. So we'd have pointing at the 1.5. When we're going to flip around the location of the variable like this, we do need to flip the symbol with it. That coming together would allow us to create our number line. And what do you want to use for the tick marks?
I was going to put is 1.5.
Well, one way to do it is 1, 2, 3. And 1.5 is right in the middle of 1 and 2. And finally, we finally got a greater than. Greater than tells us to go to the right-hand side. And so, there we go. All right, so we have this problem next to run through. And I know it's starting to seem a little bit tedious. It's like, okay, I kind of got it. But this one actually has a different structure from the ones that we've been looking at. Follow through the rest. You'll see what winds up happening when we try to solve it.
2x plus...
With distribution, we'd get 2x minus 8. With distribution gone, we'll have to combine our like terms. Our like terms with the x's, we could subtract on both sides. Jerry, you pointed out adding 10. That's another correct way to do it. It's not, remember this, our mnemonic gives us one correct way, one correct sequence. There are other correct ways of doing it. Just as long as you know something that's right, it doesn't matter. Well, what happens with 2x and 2x? It's a 0. So we wind up with 0 minus 8 is less than or equal to negative 10. And 0 minus 8 is just negative 8. Whoa, I don't know why that one was blue. So we get to this point where now we're looking at it and saying, there are no variables. What do you do when you run out of variables? Well, this is the issue that we ran into. Do you remember when we were doing equations and we ran into problems that had something like 5 is equal to 3 plus 2? And it was always true? Well, is this something that's always true or always false?
Always false.
Since negative 8 is less than or equal to negative 10, that's not true.
Not true.
This is like when we encountered a piece that said 5 equals 4. It's not true. And when it is not true, there are no solutions. The structure is a little bit different from when we were doing equation solving in that we won't say, are the two numbers equal? Instead, we'll be doing a less than, greater than comparison for, is it true or is it not? Because this is never true, it's no solutions. And our last problem we'll look at today. Okay, distributing 3x minus 12. Okay, then what? Okay, subtract the 3x, which cancels on the right, and that 0 cancels on the left. So we wind up with negative 12 plus 7 is greater than or equal to negative 20. What do you want to do next? Okay, negative 12 plus 7 gives us a negative 5. Negative 5 is greater than or equal to negative 20. Now think of a number line. Numbers that are greater than are farther left, so 0, I said that backwards. Less than is farther left, greater than is farther right. Because -5 is farther to the right than -20, it is greater than. And this is a piece that actually is true. Because this stage here is always true, it means all numbers are solutions. There is absolutely nothing that won't work. Which finishes it up. Remind you of what the learning objective was for today. We want to be able to solve inequalities that have variables on both the left and right hand side. That will include problems that have distribution. It will include problems that have decimals. It will include problems that have fractions, even though we did not do an example of that. It includes less than, greater than, or equal to, graphing, and most especially, it also includes pieces that are always or never true, letting you know there are no solutions or everything is a solution.